see two triangles, upper and lower triangular matrices. Two is we eliminate A21. Each time we apply Gauss elimination to any matrix, we will always take the matrix to a triangular matrix. A triangular matrix, upper triangular matrix. When you apply Gauss elimination on so how do we eliminate A1, A21, A31? We eliminate them using this factor A21, A31, A31, right? A31. And we eliminate the modified second and third equations. This one will be A22 prime, A32 prime. Please correct this thing. This is A32, this is A33. I hope we corrected it last time. So this will be A22 prime. And when we do that, we'll have this. See what we have, upper triangular matrix. Okay? So if I put F21, F31, F22 here, we'll get at least go back to what matrix A, but a modified matrix A. Because all this one modified, this one is modified, this is modified, this is modified, this is modified, this is modified. So this will be a modified matrix. Only question 1 is not modified. Now we can, from this place, we can see that there is also a lower triangular matrix. Okay, so all those F20, F3, F21, F31, F32, they take the place of 0, 0, 0. All right, they take place of 0, 0, 0. Then we put F2 here, F3 here, F32 here. Then along the diagonal, we put 1, 1, 1. See? So put 1, 1, 1 along the diagonal. F21, where we eliminated A21, F31, where we eliminated A31. And 2, 3, F32, where we eliminated X2. Where here was X, 3, 2 prime. Yes, here 3, 2 prime. So what we do now is we kind of generate a matrix D, a column vector D, using this lower matrix, like here. So we get with the original B given, right? We generate an intermediate vector, column vector D, right, with the lower matrix, and we can calculate all the G's using this equation. And when we finish, we use the G calculated with the upper triangular matrix to calculate the variables x1, x2 down to xn. Down to xn. That is just when we get that one, we'll do back substitution, and then we solve the rest of x. So that is the practice we did here. Using any, please mute yourself so that I don't be doing that to all of you. Let me not be muting you. Mute yourself. If you disturb, I will log it up. I'll look for the person who is not. Please. Progress. Promise. Meet yourself for next time if I call and you are on. I will meet you out. I will remove you, log you out. Let others hear. Hmm? Those ones with the name of your device, put your name there. Next class, if you don't put your name, we will mark you absent because I'm recording the names of those who are attending this class. So those are like Techno Pop One. I don't know your name. You need to write your name. MC's Mini. You need to write your name next time. If not, you will be marked absent. So please put your name instead of your device name so that we know who is here with us. Okay, so this is the problem we want to resolve using LU. All right, 3x1 minus 2x2 plus x3 plus minus 10. 2x1 plus 6x2 minus 4x3 minus equals 44. Minus x1 minus 2x2 plus 5x3 equals 26. We want to apply LU to this result for x1, x2, x3. From the above methods, F21, you can see F21. We use F21 to eliminate 2x1. And we use also F31 to eliminate minus x1, minus 1x1. When we do that, we will modify this and modify the whatever we have here is A22 prime. Whatever we have here is A32 prime. A32 prime. And then we eliminate A32 prime using A32 by A22 prime. We eliminate x2 here, and we have a triangular matrix. Okay, so that's all is there. F21 is 2, 3. To eliminate x1 there, second line, third equation, we use minus 1 over 3. All right, minus 1 over 3. And we have this result. Want to do with this one further. See, so you have A22 prime, A32 prime. Then we eliminate x2 from this side. And we have this equation here. See, it's like a triangle, upper triangular matrix. So this values here, we are not supposed to modify them, but I just did modify them to show that, as I explained last time, that this modified B would be the same value with the D we are generating. So this is after this operation, this is what we have. If it were Gaussian, we would have stopped here with this right hand, modifier right hand. We would have stopped there to calculate the values of x1, x2, x3. But LU went further. Since he did not modify the right hand side, he formulated two triangles, the upper and the lower. See the upper, then the lower, we say in the diagonal, we put 1, 1, 1, see? And then F23 is here, 0. That is 2 over 3, 0. 0.6666667. F31, and then here we corrected, it's supposed to be minus 7.333. Okay, so see it's minus 7.333. So we F32, you see what it is, 1.333 over minus 7. So this is F32. So 3 2 prime over 2 2 prime, A 2 2 prime, A 3 2 prime over A 2 2 prime. Right? So that's why we got all this one. So that is that value of F32 prime. Yeah. So we have the lower triangle. Now we will generate an intermediate matrix D, which will give us the number of right hand side B if we use gas elimination to modify it. See? So now we use the original B given. See the original B given. That is this equation here. See the original B given. We use this original B given minus 1044 minus 26 with the lower triangular matrix to generate the intermediate column vector D, which will be equal to this modified B here. Okay, equal to this one. That is the essence. All right. So now we can write the first equation. 1 times D1 plus 0 times D2 plus 0 times D3 equals 10. And so on. 6 times D1, 1 times D2, 0 times D3, minus 1, minus 3, 0.33 times D1, minus 1.81 times D2, and 1 times D3. These are the equations. So we resolve from D1, substitute D1 here, find D2, substitute D1, D2, find D3. All right, that's what is happening here. All right, that's one. So D is minus 1050 minus 20. Check it very well. Then we now use the D, this D here, with the upper triangular matrix. See the upper triangular matrix, the one we had above. And then to calculate x1, x2, x3, use back substitution. So x3 is minus 20 divided by this. We can write out the equation. See the equation 3x1 minus 2x2 x equals 10 and so on. So from here we do back substitution. Calculating x3 is 3.6 times x2 is this. We substitute back to x2 and then we substitute back to x3 and we have these values. That is just a little summarized. This is the one that we did last time. We proved it using the same method, right? Minus 3 over 10 minus 1 over 1 over 10 for F31. Then we have A22 over A32 prime. We were able to eliminate X2 in the third equation, so this is what we have. And this is upper matrix, this is lower matrix. In 10 minutes we'll be logged out. We'll come back again, so don't worry. So, and this is L from that matrix found here. So with the L and original B given, we will calculate D, generate D. That's it here. D1, D2, D3 as we did above. And we substitute D1 into D2, D1 here. To second equation, calculate D2. And substitute D1, calculate D3. That's what you have here. And this is equivalent to the one we did before. So when we use this, the equations are there, you can see. So x3, we got it minus 6, and we substitute minus 6 into this equation here to get x2, and we substitute x3 and x2 to get x1. So x1 is this, x2. So the same thing. So we will now use please, when we log out, we can log in later. We can log in immediately. So we use this same method to calculate matrix. Matrix inverse is very, very important for go each. There's another matrix A minus 1, or matrix inverse of 2. For which, if we multiply A to A minus 1, will give us identity matrix. And I told you, you know what is identity matrix? Is it the one with one in diagonal or one all over the elements? You should know identity matrix. Please look for it and learn about the properties of identity matrix. So how do we calculate the matrix inverse? It's very simple. Very, very simple. As long as you have understood how to use any decomposition. So this is because it provides an efficient means of evaluating multiple right-hand vectors. Hence, ID for evaluating the multiple vectors needed to compute the matrix inverse. What do? See, we just go straight to the algorithm. So we decompose A matrix into upper and lower triangular matrices. You have the A matrix, you decompose. That is the matrix you want to find. Now, all right, so what we do is to calculate, okay, let's say select one on the first position of the right hand side and 0 elsewhere. Huh? When we do this, we have B right hand side 1 0 0. Then with L, we calculate D. This one will be the D given this B here. With the L matrix we did here, the L matrix here, we will generate a D as we did above. We generated a D. Are you in the farm? Who is that one? Are you in the farm? Are you wearing?
Just.
Next time I will log you out too. All those who are making noise in their farm. Okay, so now with the B here, this is the B here, this is the D, and the L you got here. We can generate intermediate vector D as we usually do up there. Alright, so when we do that, we calculate that with the upper triangular matrix and the D calculated from here using this and L. Use the D, calculate x1, x2, x3, xn. This x will be the first column of the inverse matrix. Immediately you do this operation, you have the first column of the matrix inverse. The first column of the matrix inverse. After this operation, you have the first column of the matrix inverse. So you can look at matrix A. The first column will be for the first column. Then the second column now will be 0, 1, 0. And then we repeat all this. And at the end, we calculate x. That will be the second column of the A matrix. Then the third column, this will be 0, this will be 0, this will be 1. And then we repeat all this. I'll calculate x. We'll have the third column of that matrix inverse. And that will be the matrix inverse of matrix A. Very simple. Look at an example here. have done before up here.
Hello, sir.
Yeah?
Hello, sir. I'm Solomon. The last time we held this class, the pages were not in the
day to work on from this equation. All right. So what we've got is this one, upper triangular matrix, lower triangular matrix. So since we have L, we have U. We want to use L now to be generating the G's. So we want to calculate the first column of the A inverse. So we generate this, you know how we did the 1 equals 1, D1 equals 1, and then 0 minus.
Sir, please, I have questions, sir.
You will ask.
Can I ask questions, sir?
You will ask, just hold on. Let me finish this line here. So you can calculate D as we did over the D, the values you will get is 1, 0.3, minus 0.055555. That is the D. And then with the upper triangular matrix here, with this D you calculated now, this D, see the D, then you calculate x1, x2, x3 of the A inverse. So this is the first column to calculate x1, x2, x3. So use your hand and write A, write the first column. First column, right? First element, second element, under that first column. Then you see it here. This is the first column of the matrix inverse. Those values we got. Then we do the same thing as I told you. On the right hand side B, we substitute 0 in the first element of this right hand column vector, and then 1 because we want to calculate the second column. We put 1 on the second position of the big column vector, and then we calculate D1, D2, D3 as usual, and that is the value of D1, D2, D3. So you repeat that first process so to calculate all this one, and then you use this D and the upper triangular matrix. So you calculate x1, x2, x3. You see the values of the D. Yeah. Then from there you generate with this U, you generate first element, second element. That will give us the second column of the matrix inverse. See, very simple. Then again, you do the same thing. The B, you put 0, 0, 1. See, 0, 0, 1. Right hand side column vector. And you solve for D, that's what you have. Then after you solve for X, and X is this 0, 0, 5, 1, 8, which is the final column. That's it. So this is the matrix inverse of this matrix here. You can see how simple it is. See, this is the matrix inverse. This is the matrix inverse. You know? Matrix inverse of this one here. See? Let's say I wanted to see if I could paste it side by side. Right? I wanted to see if I could paste it side by side. Let's see if I can paste it here. Let's see whether it will come. It did not come here. Well, leave it. So this is the matrix inverse of that A matrix. right? And then we can always calculate A times A minus 1 that gives you identity matrix. If you multiply this matrix and the first one over there, and you get I, then you know, try it. See, we are doing masters, so we can always try certain things that are worked for us. Like this one now. If I were you, I would just multiply A by A minus 1, see what I will get. You will love it. You will love it. So if you can always generate your matrix, identity matrix, from any given matrix. You do the decomposition, multiply it by its inverse, and you get matrix inverse. And that's why I say look for the meaning of matrix inverse, and you will appreciate it. You will appreciate it. So do it. So that is just all about matrix inverse using LU. Very, very important. Matrix inverse. Okay, just go ahead and read it again and see what you can make out of it. You will enjoy it. All right, so these are some exercises you want to do. Let's move to what we are actually for today. That is chapter 5. Chapter 5. Chapter 5. Gauss-Seidel, Jacobi iteration, and realization. So I have this system of equation which we are used to now. A11, X1, A31 down to B3. We have that equation. We are used to it. So Gauss-Seidel has this structure. As long as A11, A22, A33 are not equal to 0, we can apply Gauss elimination because the diagonal elements are non-zero. So what we do is that from equation 1, 5a, we make x1 the subject of the others. Look at it, x1, b1 minus a12, a12, x2, right? Because we are carrying a12, x2, a13, x3 to this side. That's why it's the b1 minus this divided by a11. That will give you x1. Then go to equation 2. Do the same thing. Carry all this one, a22, x2, a23, x3 to this side. So b2. I mean, a21, x1. Since we want to make x2 the subject of this, and this. So it will be b2 minus a21, x1 minus a23, x3 all over a22. That's it. We do the same thing here for a33, x3. x3 is the one we are looking for now. We do it on the third equation. Don't forget, x1 we do it on the first equation. x2 we do it on the second equation. x3 we do it on the third equation. So please don't do x3 on the first equation. It's with respect to their various equations. x1 is first equation, x2 second equation, x3 third equation, like a triangle using this diagonal. And that's what you have here. So what is the strategy? Strategy, we have a guess for the x, all of them. So simplest way is to make all of them 0. x1 equals x2 equals x3 equals 0. And then we calculate x1. To calculate x1, x2 will be 0, x3 will be 0, b2 divided by a11. Are you not hearing me? Why? Is everybody hearing me?
We are hearing you clearly.
Yes, sir.
Every day at 9. If you pray all week, they will not take my we are winning every week.
Who is that? Who is that? Can't be disturbing us. So I said for this equation, this is the structure of Gauss-Seidel equation. And we can put initial guesses to be 0, all of them. These zeros are substituted into the equation 5a to determine the new value of x1. This new value of x1 is substituted immediately into 5b to calculate the new value of x2. And finally, this new value of x is substituted into c to calculate the new value of x3. This procedure is continued until the system converges to an acceptable percentage error. Please look at equation 5.2. This thing is x. Is x, not epsilon. Is x. See, I'm correcting them. Is x. So this is the present x minus the previous x divided by the present x. Again, absolute value. The epsilon a approximate or error or estimate error will be less than stopping criteria, the stopping error. All right, and don't forget that this equation is for all I and j, right? And I said j, j is the present and this is the previous iteration. Quickly, let's see this example. Use Gauss-Seidel method to solve for the system. So you see the system, 7c1 minus 2c2 minus 2c3 equals 500. Minus c1 plus 2c2 minus 2c3 equals 200. Minus c1 minus 5c1 minus 5c2 plus 22c3 equals 30. So first equation will make c1 the subject of c2, c3. That's what we have here, 5.3. And this one we make c2 the subject of c1, c3, and 200. That's what we have here. Then c3, we do the same thing. c3 the subject of c1, c2, and 30. That's what we have here. As we say, first iteration, all is 0. If we substitute 0 here, C2 0, C3 0, you have 500 over 17. 500 over 17. 29.4118. Then we quickly substitute this one to calculate for x2 or C2. See, C2. This is the equation for C2. So we have 5C1. C3 is still 0. 200 plus 5 times C1, which we calculated, 29 point this thing. And we have this one. And then we use the value of C2 and C1, substitute them immediately to calculate C3. First iteration is over. First iteration is over. All right, now, second iteration, you begin to collect the previous values. For C2, this is the value for C2. This is the value for C1. You calculate it immediately. C1, a new C1. You substitute this new C1 straight to calculate C2. We maintain C3, the previous one we have calculated. We substitute it here. To calculate C2. Now, we have C2. We have C1. C2. Have C1. C2. C1, C2. We substitute immediately. Okay? Then, the second iteration is finished. And you continue doing like that. Substitute C1. for third iteration, we substitute C2, substitute C3, calculate new C1, and we substitute this immediate C1 and the previous C3, calculate C2. I will calculate the immediate C1 and immediate C2, calculate C3. So you keep doing that. About six iterations, you have these values here. You convert this to 6 values. Okay? You can always calculate the error. Present minus the past over the present for the third iteration. This is present C1. The previous is at 3.4. The present is at 3.9. So it is the present minus the previous divided by the present. That's what you are seeing. The present minus the previous divided by the present. It gives us 1.44%. And I want to say something. %. Money. The difference is that you can use the structure, but when you calculate the new x, you keep it. You don't substitute immediately. They are just stored for next iteration. In each iteration, you calculate x1, x2, x3. Remember, in gas said when we calculate x1, we substitute it into the second equation to calculate x2. And then we carry the values of x1 and x2 to substitute in the third equation, and we calculate x3. That's what we were doing. Right? So, you see, the values calculated are not immediately substituted into the next equation. Every other thing remains the same, except I want 2 here. We have 10 minutes longer here. So let's see. That same equation, that same example, 5.1 here. Example 5.1. We do all that we did. We do this one, we do this one, we do this one. Make the unknown the subject of each of the tests in respective equations. So then we apply Jacobi. See, we have C1, C2, C3. The first iteration, C2, C3 equals 0. So we substitute. And we have 500 over 17. That is C1. We keep it. We will substitute immediately. Then we calculate C2. Since all of them are still 0, it will be 200 over 31. We have this. We will not substitute immediately. We keep it. Then we calculate C3. All of them are still 0, 0. We calculate C3. 30 over 32. We have it here. First iteration is over. We go to second iteration. Now we use these values we are calculated in the first iteration to be substituting into the second iteration. And then we keep the result. See? C1. We have C2. We have C3. C2, C3. We calculate C1. We keep it. Then C2. See, we are not using C1. We go back here. We calculate the C1 we calculated. That's the one we are going to use. We calculate C2. And we did not use this any one here. With the previous one, previous iteration, C3. Put it here, calculate C2. We keep it. We do not substitute immediately. Then we calculate C3 using the previous values of C1 and C2. See, C1, 29. minus the past divided by the present minus the previous divided by the present absolute times 100 must be less than echelon stopping criterion. All right. 5.3 realization. We say realization x is computed. That value of x is modified by a weighted average. Okay, by a weighted average of the result of the previous and present iterations. So, for example, we have 33. We will modify the value using this expression. The value we have modified is this one. This is the value we have calculated. This is the previous one. Lambda is the weighted value. It's a weighted average, like a perturbation fraction, very small fraction to enhance convergence. So it says if lambda is 1, 1 minus 1 is 0. We don't have anything here. This one equal to this one. We have not done anything. The result is not modified. However, if lambda is between 0 and 1, 0.5, 0.001, 0.9, as long as it's not equal to 1, the result is a weighted average of present and previous result. This modification is called under realization. And hastens convergence by damping out oscillations, the amplitude of vibration, right? You dampen it and reduce the amplitude. You know, when like sinusoidal something, the amplitude will be reduced by this weighted average. However, if lambda is between 1 and 2, extra weight is placed on the present value to accelerate the convergence of already converging system. This is called over-realization, or it is also a successive or simultaneous over-realization, or SOR. So when you see SOR, you are saying successive or simultaneous over-realization, SOR. That is choosing a value of lambda between 1 and 2. So we can quickly illustrate it here. This is lambda. This is lambda. That is lambda. That is lambda. Yeah, not delta, lambda. That's what we have up here. Lambda. In 2 minutes, we will be logged out, and we'll come back for the final 40 minutes.
Wonderful, sir.
So, we have 3x1 minus this, that, and this equal to that, this equal to that. When we log out, we'll come back for the last 40 minutes. So, please, hold on, so that we can finish this, and then we ask questions, and then we'll go for the debate. Alright, so this is the question we want to resolve now using Gauss search. The answers are 3 minus 2.5 and 7. So we are using Gauss 7. We say we should use Gauss 7. You can use Jacobi iteration to say Gauss 7 with realization of lambda not theta equals 0.9. So look at first solve each for each unknown on the diagonal. X1 is this, X2 is this, X is that from here. Make X1 the subject of the rest, x2 the subject of the rest, x3 for each for the respective equations. All right. So first iteration, x equals 0 plus s3. So substitute here. This is 2.61666667. Then we relax immediately x1. You must relax it before you substitute to calculate x2. See, we relax the x1 we calculated, substituting it into realization equation. See the equation here, 5.3. All right, so we have 0.9, which is lambda times the x1 we calculated, 1 minus lambda 0.9 times the previous, which is 0. Previous x1 is 0. And when we simplify this, we have less than 1 minute. When we simplify, we have this 2.35. You see, that is the one we are substituting to calculate x. So we didn't substitute 2.616666. No, we substitute 2.350003. That is the one we substitute. This is the one that we relaxed. Okay, this one, if you check this number, this is oscillatory. If you look at it here, it's oscillatory. You see how it's repeating itself? It's oscillatory. All right. So this of gas schedule using realization. I hope you are seeing my screen. So we have first iteration. X1 is 0, x2 is 0, x3 is everything is 0. So we substitute the zeros for x2 and x3, and we have this. Then we relax this value, 263. That is this new value here. But by multiplying it by the lambda, we have 0.9. And the old equation, we have this. We now use this very one, x1 we have gotten, to calculate for x2. You see the value. Calculate x2, you see it. And then we pick the x3 above in the previous iteration. That modified x3 in first iteration. That's what is here. You see, everything you are using will be the modified. So this is the modified x1. This is modified x3. We got x2, unmodified x. Then we modify x2 again using the previous values of x2. This was the previous value of x2 from that equation 5.3. And this is the present value. We want to get the relaxed value x2. That's what it is. And then we substitute it straight now using the modified x1 under that iteration, and then the modified x2 under that iteration. We get x3. So when we have x3, we also relax x3. See, we relax x3. So we keep going. If you want, this is 7. Is going towards the expected value, right? 3 minus 2.57. So you can go ahead and finish the iteration. And the error is this. This is the error. All right. So let's ask question. Any question for this one before I show you non-linear system? Close for the day.
No, non-linear system exists today. Let's have something criteria.
Is the same? I'm not taking too much. Is it too much?
Yes, it's not bold. It's not bold.
It's too much.
So it's not bold.
Let's stop here. Mind you, that book you have in hand will finish. Do you understand? Even if we stop now, we stop here, we go forward. That book you have must finish in this semester.
We will finish this, sir.
Okay.
It is good when you are following, it will good for us to catch up also.
Okay, but are you following for the one we are?
Yes, we are following. Let's start today.
Okay, let's go to let's talk about any what we want today is just very simple. And I wanted to finish this topic today because the last one is non-linear. But if you want us to stop today,
let's stop, please.
all right.
Just 2 hours now. Let's
Okay.
finish this, then we are done.
I did not follow this class, sir.
Wisdom. Who is talking? Is it wisdom or who? Like
Wisdom is talking
I
here,
did
sir.
not follow. I did not follow this class, sir.
This
That
is
is not wisdom.
Hello, sir.
this is the most relaxed class. Oh.
No,
Yes, sir.
I have to be honest with you. Maybe it's because of when I came into the class. I wasn't even aware of the class, sir.
Who is speaking that one?
Is Dan Dixon, your colleague, agric engineering? I was calling you earlier this morning.
Wait. You didn't know about this class or you forgot?
No. Honestly, normally when we start the class, you send us
Okay, no, but I had
information on
already.
the way to log in, and I've been on the platform monitoring. I didn't see anything,
Oh.
and I called you severally. You didn't take.
Because sorry. Sorry. We had already stated.
Please, I have a question.
Go ahead. Ask if you have any question in what we have done so far. Please go ahead.
Sir, please, my question is on your example 4.1. I tried it.